This is another a very interesting phenomenon, especially in our connector. In this application of the connector, especially high voltage and high current connectors, our customers are choosing or use. When this high voltage and high current connector, it usually has an electrical safety indicator. Well, in addition to our operating current voltage, or other than this contact resistance, we also have a metric called insulation resistance. This insulation resistance is weird. It actually measures our insulators. This insulation strength, it's our kind of this engineering plastic used for protection or do protection, do this electrical industry, creepage distance. These insulating materials in the middle, it is to measure the insulation strength of this insulating material. It's also very simple to test. You take a multimeter to your insulator. You can click on the two different locations, right? It can generate a so-called this insulating strength, this value. But what? What about this insulation resistance? It's very closely related to humidity. It's better than what we call voltage resistance. What about some other metrics? The correlation with this humidity is stronger. We have a lot of materials. Above functional materials, there is something called the leakage mark index. What about it? In fact, it is similar to our effect of humidity on buildings. And the principle is pretty much the same. You're on a standard insulator. For example, this is me. This is my standard insulator. Now if you say, if I were on the surface of this insulator, suppose there is a trail of water. This trace of water is not necessarily regular, right? As long as there is water environment. Everyone, you know, water, it's almost a conductor of this electricity. So what if I'm on the surface of this insulator? Apply a TV on either end of it, or voltage. As long as it's on both ends of the water. This is called electricity, voltage potential. What about its voltage and electricity and potential? It will make some of your so-called electricity, electron molecule. It's going along your conductor. Is it easier to spread electrons? In some directions. What it does is it creates this massive electrical movement. Then this so-called leakage mark index, including the impact of our water. It's actually based on this principle. All right, under normal circumstances, at our room temperature, under normal circumstances, there is no water on this surface. So our material, when it measures the insulation resistance, we can measure the resistance in G, or at least a few hundred trillion euros. Such a resistor, this is normal. Because of our engineering plastic surfaces, conductivity, it's that high. But there is a very special case. For example, in our southern China, this so-called plum rain season, back to Nanchen. In this case, when it is on the surface, it is stronger. When is this watermark? Sorry about that. It's insulation resistance. When we test, this insulation resistance is under the same conditions. This insulation resistance will drop very sharply. Very impressive. So it has a very interesting phenomenon. We have a lot more than, say, this kind of connection used for this. Is this our car? Battery? Or some of our elevator equipment. When we do acceptance, obviously I ship it. Its insulation resistance can be greater than or equal to, for example, 50 go or 500 trillion. Is there any problem? When we ship, it's no problem when doing acceptance, but suddenly waiting for us when we get to production and use it. And we found out its inductance may be less than 20 trillion ohms, even 10 trillion. It's a very interesting phenomenon. How can we judge at this time? Does it meet our requirements? Does not meet our requirements. This is actually in real-world applications. Does it happen often? There are some that we do this quality management. Some are engineers. Are we right about this place? I found out what is this called. More confusing. Now, there's an underlying condition. That is to say, when we measure the insulation resistance, it has an implicit condition. First, it should be a standard test condition. That is to say, we usually call it room temperature conditions. The second one in the process, we should define relative humidity because many indicators it has there is one that you set this indicator for, a corresponding premise, just insulation resistance. It is related to the indicator of relative humidity. It's a very strong connection, very strong so many indicators. For example, what temperature rise do we define? Define this pressure. We have some preconditions. Because the correlation is weak, it's the only relationship. We rarely make it that clear, but the insulation resistance is different. Insulation resistance because of it and its effect on humidity, or it will be very affected by humidity. So we usually talk about it. Our relative humidity. For example, 50% of the phase. Yes, the humidity. Related humidity. Yeah, it's one like this. Or let's order another one. Can both parties accept it? Then this is a lot of times we need to go to the household. With customers, talk about an acceptable standard.